Hello everybody and welcome to another session on Hack with Infy. Firstly, I hope you're all keeping safe. It's really getting wild out there. And today's session is going to be divided again into three parts as usual. Number one, what's the syllabus for Hack with Infy? By now you should all know, but still for those of you who are joining new, I'll tell you what the syllabus is. Number two, how we can help you prepare for Hack with Infy. And number three, the actual solution to the question called minimum withdrawals in an ATM and so on. So that kind of question. If you just want to go ahead and just check out the question, you can go to this link or the link in the description below, and we have the question over there. So without further delay, let's actually get started. This is the syllabus for Hack with Infy. Arrays questions. They love to ask arrays questions on binary search, two pointers, prefix sums, those kind of things. Data structures like stacks, maps, a little bit of trees and graphs as well as questions on backtracking and DP. All of these and more are covered in our advanced algos and data structures course. So if you've been following us since then, if you're part of the advanced algos data structures course, all of these questions shouldn't be too difficult for you. For those of you who are not, we have all of this prepared in our Hack with Infy preparation course, which we have been doing regular classes to help you cope up with the Hack with Infy questions. We've been doing mock tests as well. All of the previous year's topics are covered. We have mentors who can help you, who can solve your doubts throughout the day. And yeah, the link is in the description below for if you want to access this course. Just a friendly reminder that we have about 2 doubt clearing sessions remaining before we go into Hack with Infy. So if you are someone who's not yet signed up for this course, you can still sign up, check out the recordings of the previous classes, and also be part of this revision class or the doubt clearing class, which is going to be held on 3rd and 4th of May. And on these 2 days, you can ask any doubts, any logical doubts, any syllabus doubt that you have, and I will try my best to solve it for you. Today's question is called as minimum withdrawals or minimum ATM withdrawals. And that question, I'll just be opening it. Just give me 1 second. Yeah, that question is called minimum ATM withdrawals. And that question, by the way, is available for anybody who's registered for Hack with Infy, not on our platform, even on the actual Hack with Infy platform. You just need to be registered there. And if you're registered there in the sample test, this question is there. This is, I would say, the medium level question of this time sample paper. The difficult question is minimum pluses, which we'll be releasing a tutorial on shortly. So without further delay, let's look at this question called as minimum ATM withdrawals. For that, you will need to open up the Hack with Infy course on Edyst. So this is what that looks like. Once you click on the link in the description below, you'll be opening up this page. You just have to click try one free module now. Once you do that, it opens up this course over here. And in this course, obviously this is a paid course, so this will be locked for you, some of it. You just need to click on this basic concepts practice. In that, I'll go to arrays, and in arrays I just have to click minimum ATM withdrawals, and the question is there. So let's get started. The question says there is a unique ATM in Wonderland. Imagine this ATM as an array of numbers. You can withdraw cash only from either ends of the array. Sarah wants to withdraw X amount of cash from the ATM. What are the minimum number of withdrawals? Now notice, they've not said is it possible or not possible. They're not asking. They're asking what is the minimum number of withdrawals that Sarah would need to accumulate X amount of cash. Okay, if it is not possible, then you print -1. If it is possible, then you have to print the minimum number of withdrawals. Okay, all right, so this is an important part of it. So now let's first understand the question a little bit further. The example input they have given is slightly useless. They've said that there is 2 elements in the array 1 and 1. There are 2 elements in the array 1 and 1, and I want to withdraw 3. So obviously this is an edge case. If you want to withdraw more amount than there is in the ATM, then you can't really withdraw. But this doesn't really help us out in our logic of the question. So as I always suggest, take up another example and try to build the logic for that. So I've taken another example over here in the form of this array. So imagine you're given this array here. These are the indexes 0 till 5, and this is the array 1, 7, 15, 2, 3, and 6. Okay, now I've given this sort of an array, and I'm asking you, is 15 possible to withdraw? Here I would highly suggest pause the video, try to figure out if 15 is possible to withdraw. In this case, let's see if 15 is possible. I could withdraw 1 and I could withdraw 6. I would need 8 more because 6 plus 1 is 7. So I would take 9 from here and 2, but this gives me up till a sum of 12 only. Okay, if I take this, it gives me a sum of 19. So I can't really do that. Let's say I let go of the 2. This gives me a sum of 17. Let's say I let go of the 3. This gives me a sum of 14. I'm not able to reach 15 properly. I could reach 1 plus 7 plus 6. I could reach 1 plus 7, I could reach only 6, but I can't reach 15 properly. So 15 is not possible. Okay. What about if let's say I'm trying to reach 16? If I'm trying to reach 16, okay. So let's say if I want to reach 16, I say, okay, I take 1 and 6 is 7. If I take this one, this will be 14, but then this is helping me reach 17. I can't really reach 16, and no matter how else you spin it, let's say I don't take this 7, I take this 2, I'm going to reach 12, but then I end up reaching 27 if I end up taking this 15. So again, 16 is not possible. Okay, let's look at 17, and yes, 17 is possible because we just saw it, right? I could take 1 plus 7, this is 8. I could take this 6, 14 plus 3, 17. 17 is possible, and minimum withdrawals will be 4 withdrawals, right? I'm saying here that I will take 4 withdrawals for 17. Okay, all right. So with this example, I'm getting some sort of an answer, right? But not sure of exactly. Like, yeah, I could try from either end, but the problem is I'm not really sure on how to proceed. Like, I selected 1, but should I continue by selecting 1, 7 and 15? Should I continue by selecting 1 and 6 and 3? How is it exactly I'm supposed to proceed? Those of you who've done a little bit of algos and data structures, you would notice that there is this algorithm called 2 pointers. In 2 pointers though, there are 2 things that we always take into consideration. One is that the array must be sorted, or at least 99% of the time a sorted array helps out. And the second thing is moving my left and right pointer follows a certain rule. If I want to increase my sum, decrease my sum, increase my number, I can move the pointer left and right. Here, let's say I'm faced with the choice of, I selected 1 from here, I selected 6 from here. I want to reach, let's say 15. Moving both the pointers can help me reach 15. I cannot definitively say which side or which end I should pursue further, right? That is my problem here. So let's dig deeper into this and try to figure out what's happening. So let's take this example, this next one, and I'm trying to figure out 18. Is 18 possible or not in this one? This 18, I'm checking the second array. Now in the second array, again, I could start from 1, and I take here, it becomes 7. This becomes 10, this becomes 12, this becomes 13, and this becomes 18. So yes, 18 is possible, and I'm reaching 18 here in how many moves? I'm reaching here in 6 moves. So I got 6 for 18 over here. Okay, is that the best I could do though? Because I have to do the minimum number of withdrawals, because I didn't even consider the other side. I do 1 and 3 is 4. If I take this, it's 12, and I then take this 6, it's 18. So actually I would have been better off if I took 2 elements from the right side and 2 elements from the left side. Yeah, but how do I choose, right? So because here for 6, I'm saying better than 6 is actually 4, because within 4 withdrawals I'm getting the answer. But how do I choose whether I should pursue my left end further or should I pursue my right end further? Now, if you've not seen this question before, if you've not even checked it out in the sample paper of HackWithInfy, I would highly urge you, pause right now, because I'm about to tell you the logic. And once you get the logic, then it's no fun then to code it yourself. So do pause the video, try to figure out the logic yourself. And for those of you who just want to know the logic, we'll just continue right away. Okay, so let's say this is, forget this array for now. Let's try to figure out the array that we're trying to do, and we're saying that, let's say 18 is the answer that we're looking for, right? So let's say for somehow I'm just going to take this up a little bit below so that one is out of sight. Okay, what we know finally is I will have some or none elements from here, and I will have some and or none elements from here, right? This is how my final array is going to look like. My final minimum withdrawals that I'm going to take some elements from the left and some elements from the right. What I will never have, what I'm never going to have is something like this, right? So let's say this is the case. I'm never going to be selecting things like, one second, take some element here, this element here, this element here, this element here. I'm never going to be doing this because I can only withdraw from the ends. I can't skip any element. So I will always take from the middle, some part of the middle. That middle could be from the start till the middle, could be from the end till the middle, but it is always going to be a continuous thing. That is, I'm always going to take like this, the part that I'm going to leave out, I mean to say, the part I'm going to leave out is always going to be a continuous strip, right? I'm going to take from the start till here and then from some point till the end, but I'm never going to leave out, spots. I'm not going to leave it out like this. There's never going to be any gaps between the numbers I choose, okay? So now let's flip the question. Okay, whenever you get something like this, try to figure out all the ways. What we can say for sure is these parts, if I sum them up, they're going to be x, right? This yellow part, which means that if I try to sum up this part over here, sorry, if I try to sum up this part over here, what is it going to be? This part, one second, yeah. So this part is going to be sum of a minus x. This is what I'm expecting from this part. So now my question comes down to, in my array, forget the ends, in the middle, is there a sub array whose sum sums up to the sum of a minus x, right? The sum should sum up to the sum of a minus x. And this is not a difficult problem to solve. This is actually a two pointers approach. Okay, for those of you guys don't know two pointers approach, I'm just share the approach a little bit right now, but that's what it comes down to, right? Now the question also doesn't just come down to, is there an a sum of array minus x? For example, if I had taken up this one, right, the entire sum of this array is 53. You can sum it up yourself and see it's 53. If I want 18, so what I'm actually looking for is 53 minus 18, which is 35. I'm looking for a mid array whose sum is 35. Now in 35, you actually have two arrays which are giving you 35. What are those two arrays? Well, you could have, one second, no, not this one. Yeah, I guess from here. No. What did we say? We said, one second. The sum of the entire array is 53. I want 53 minus 18 is going to be 35. Yeah, it's going to be 35. So what is the mid array that gives me a sum of 35? See, this is the answer that we had selected. One second. No, this is not the answer. Yeah, this was the, yeah, this, one second. I forgot the answer that we had selected for 18. Yeah, this was the answer we had selected. So if you actually look at it here, this sum is 35. 12 up till 3 is 35. This is one of the answers that you can get. So this is one of the arrays that gives you 35. But this array is of how much size? So wait, this also gives you 35 over here. This is 35 with how many? 5 elements. 5 elements. Yep, this is 35 with 5 elements over here. Okay, and not minus 5, this is 35 with 5 elements over here. You also have another one which is 35, which is, if I had taken up, for example, something like this, this also gives me 18 sum. That means that this part over here is also 35, right? This part which also gives us a sum of 35, which means that something like this would also give me a sum of 35. But this time I have many more elements over here. So if I'm going to take up, this entire thing, it's from 2 up until 8. How many elements do I have over here? I have 1, 2, 3, 4, 5, 6, 7 elements here, right? I have 7 elements over here, right? So I have 35, but the sum is 7 elements. Obviously, I will prefer this one because this will mean that my x, which is from the other side, right? These elements, right? If I wanted to pick this, my x, which is this, will be more, that, or will be lesser. We want the minimum withdrawal. So the bigger my sub array inside, the lesser withdrawals I have to do from either end. The minimum the sub array inside, or the longer the sub array inside, the more or the lesser withdrawals I'll have to do. Again, repeating, the longer the sub array inside, the lesser withdrawals I have to do from left and right. Okay, so the better it is for me. Okay, so I don't only have to find sum of a minus x, I also have to find the largest sub array whose answer is sum of a minus x. The largest sub array whose sum gives me sum of a minus x, right? If there is no such sub array, then you print -1. If there is such a sub array, try to find the largest one. Okay, so that's what the final answer boils down to. Now let's try our approach. What our approach is going to look like is something like this, where what we're going to do is we're going to say start from the first two numbers, start from a of I and a of j. Okay, and your target, by the way, so let's say hold on. Yeah, so what I got here was that take input the target, let's say, which is x. Take input x. My target is equal to sum of a. You have to take input a also, sum of a minus x, right? Now the easiest thing that you could do is also, if x is greater than sum of a, right, minus 1. Print minus 1, it's just not possible. If x is greater than sum of a, just print minus 1, it's not possible. Otherwise, you start from a of I comma j, and where not a of I comma j, you start from, let's say I is equal to 0, j is equal to 1. I'm trying to find that aij which has the largest, which is the largest subarray whose sum actually meets my sum, which is the target sum that I'm looking for, right? So I'm going to do I over here, target is equal to this, and you're going to keep going. You'll say that, current sum is equal to a of I up till, or a of I, sum of a of I till j. Okay, so this is the current sum is equal to this. Okay, if current sum is less than target, then you move your j pointer forward, because you want to increase the target. So you say j is equal to j plus 1. However, if the current sum is, one second, let me just get rid of this, right? So if the current sum is equal to this, if current sum is less than target, you move your j pointer forward. Else what you do is, right, else you have to move your else if, but rather else if, because it could just happen that it's equal, right? So else if current sum is greater than target, then you move your left pointer forward, right, to decrease the sum. So you say that I is equal to I plus 1, which is your left pointer, right? You could, instead of using I and j, you could also use left and right over here. So you're going to move your left pointer forward. What does that mean? Let me just show you what this means. Let's say I started over here. Okay, I started at, let's say 1. I see that I take 1 plus 6, which is 7, and I say that, what am I looking for? I am looking for 35, right? I'm looking for 35. 7 is lesser than 35. Increase, 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 always increase. You will reach this case where you have 37 over here, right? Sorry, increase, 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 and increase. This sum becomes 38. If this sum has become 38, now I have to decrease the sum. How will you decrease? Let the left part go. Now the sum has become 37. Let the left part go. Now the sum has become 31. Lesser than 35, increase the sum. Now it becomes 35. So increase the right side. So whenever you want to increase the sum, increase the right side. Whenever you want to decrease the sum, you decrease the left side. Otherwise, if it's equal, then you found your I and j, right? You found your I and j. So check current length is equal to j minus I plus 1. This is the length of the subarray here. You want to get the maximum such subarray. You want to get the maximum such subarray. So what you're going to do is, okay, this is one of the thing. Okay, and you say that max length is equal to max of max length and current length. You don't stop here. If you would have stopped here if you wanted to check is it possible, but you don't stop here. What you do is you go further. What is max length? Initially you can take max length as 0. Let's say max length is equal to 0, all right, initially. And then what you do is, every time you get a new length, you just keep increasing your length. Again, everyone, this is just the pseudo code. So then after that, I take this, and then what I should do is I should continue forward. I shouldn't just leave with this. I should actually try to continue forward. I'll say j is equal to j plus 1. Move the right pointer again, because you could have had a 0 on the right side. So try to move the right pointer again, okay, and try to increase the length of this. Or if you didn't have a 0, just increase the sum. Now the sum is greater. Now I will automatically increase from the left side, right? So try to get even a bigger sub array than this one. So increase j by 1, and you'll get, this will keep going forward. Finally, this all has to be in a loop, right? So your loop over here is going to be like, while I is less than len of a and j is less than len of a as well, right? And you'll keep going forward with this one, right? Okay, so in this case, now the answer is not your current I and j, by the way. You got a particular length. Your answer will finally be equal to, you got I and j as the biggest subarray. It's going to be n minus current length, right? So you got the biggest subarray of current length, not current length, max length, sorry. So it's going to be max length. So you got the biggest array of max length. You got the biggest subarray of max length, and minus that will give you the minimum ATM withdrawals you need to take. Obviously, if the max length was still 0, then you have to check whether n actually is possible if sum of array is equal to x if the sum of array is equal to x, you print out 0, that you don't need, no, you don't, sorry, if sum of array is equal to x, then you need the entire array, right? So the answer will be n over there. Otherwise, so those are couple of edge cases. What are the edge cases? If let's say you get that max line is n itself, all right, sorry, max line is not n, max line is 0. If it's 0, you have to check for whether we actually got any other value, or you know, it's just 0 because of the default value of 0. So just check that. When is max line going to be 0? Max line is going to be 0 when you found that the entire subarray has to be taken, or you didn't really update any value. So if max line is 0, all you need to do is say that check if sum of array is equal to target. I'll just show you. Instead of saying all of these things, let me just show you what is the edge case over here. The edge case that you get over here is like this. It could just so happen that the entire subarray you get nothing over here, because for example, let's say the x was 53. Let's say the x itself was 53. Then the target would be sum of a minus x, which is 0. So you are going to get that if I want a subarray of length 0, then subarray of sum 0, I have to take a subarray of length 0. Your max length is going to be 0. But in that case, it's not impossible. It's just that you have to take the entire array to make the cache of 53. So there you have two edge cases over here. The edge case is as follows. Okay, second, just writing the edge case over here. The edge case will look like this. If max len is equal to 0, then if n is equal to sum of a, right, then what you do, you print n, because you need n withdrawals, right? Otherwise it's not equal to sum of a and we're still not able to do it, so you print -1. Okay, means that I couldn't get even a single sub array to match this length, right? That's what it means over here, right? Otherwise, even if a single sub array would have been matched, then this max len would have got initialized, but it didn't get initialized. That means I couldn't find a single sub array to get target minus x. Therefore x itself doesn't exist, right? Sum of a minus x, which is target, I couldn't get target, which means x also is not possible to get over here. Now a couple of notes over here, everybody. This sum of aij is not something you calculate every time. Okay, if you do sum of aij every time, that's an order n calculation. Don't use the inbuilt function sum aij. Simply put, every time you increase or decrease your index, increase or decrease the sum accordingly. So current sum, if j is j plus 1, current sum is current sum plus a of j. If I is I plus 1, current sum is current sum minus a of i. That's what you should do. Okay, so that's the pseudo code. If you want the full code for this one, all you need to do is open up the question on the Edyst platform. You can just go to the hint section. On the hint section, we have the complete code. You can just click unlock and you'll get the complete code for this question on the Edyst platform. Do try it out. I'll actually just unlock and quickly show you that this works. I mean, yeah, it definitely does work, but anyways, I'm just showing it to you, all of you, that yes, it does work. The solution approach is order n time. It's order n time. So I just submit it, and as you can see, this works. And not only does it work over here, by the way, as I've been promising all of you, we have solved this on the HackWithInfy platform, and it passes all of the 14 test cases. I'm not sure you can see, but this is a screenshot from them. Passes all the 14 test cases, and you can just sign in and get the code for this question over there. So yes, everybody, that's mainly it from our side. If you would like us to cover some more questions, put it in the comments below. We'll have a look at it. Even this question was suggested by one of you and we've covered it right now. So do let us know in the comments below. Hope you like this video. Hope you're liking our HackWithInfy coverage. Subscribe to this channel. We'll be giving you more up-to-date HackWithInfy questions as and when HackWithInfy happens. And yeah, share this video with anybody who's preparing for HackWithInfy. Wishing you all the best for all upcoming placement series, and yeah, also wishing you and your family members and all your loved ones the best of health. We need all of your prayers to get through this tough time that's going on right now in our country. Thanks all for joining in today, and I'll see you all next time. All the best.